Hello viewers, welcome to our webinar training. This is Elgon, Kenya. We are located in Nairobi, Eastgate Road off Mombasa Road. Elgon, Kenya, we deal in agrochemicals. We also deal in packaging solutions, irrigation, seeds, animal health, fertilizers, and as you can see, this is a full basket that our farmers, anything that our farmers may need concerning the farming, here at Elgon, we have everything. Let's go straight to some of the products that we have in fertilizers before we start our the basic of crop nutrition. Some of the fertilizers, just to mention a few, we have our WT. At this time, let me reiterate that our brand name is WT. So we have WT DAP, WT CAN, WT Urea, WT NPK 1717, WT 23230. We have other specialty products, semi-specialty products like Granny Potash. We also have K-Leaf, this is a foliar, Nutrivant, this is a foliar also, full range of foliars. We have some water-soluble fertilizers, like for example, potassium nitrate, calcium nitrate, potassium sulfate, MAP, MKP, magnesium sulfate, and many others products that really are used in fertigation. So we'll go straight to the basic about the crop nutrition. I know you know them. At one time, we learned this in school, probably in colleges. I know some of our farmers, probably you have done other careers, but you are now involved in farming. Therefore, let me go straight to the basic, and I will share some few slides. Some few slides here. Yes, those are some of the products. What does a plant need to live? For a plant to survive, what does it need? Just like we human beings, we have food, we have meals. Same case with the plants. The plant requires the following. It requires water. It also requires sunlight, CO2 and oxygen, and also the nutrients, the various nutrients that could be found in the soil, and some of them coming from fertilizers. These are nitrogen, phosphorus, potassium, calcium, magnesium, sulfur, iron, zinc, copper, boron, manganese, molybdenum, and even chlorine. I've just mentioned that we human beings, with balanced diet, we will do very well. The same case with the plants. Plants also requires balanced diet. And this you can see in that circle, having everything that plant requires, both the macro and the micro nutrients. Now, what will happen if you grow, for instance, your maize without putting fertilizers? You can see the front picture, the front photo of the maize that look pale, look yellowish. That maize is grown without nitrogen, phosphorus, and potassium. But look at the back. So when you apply fertilizers, that is how your maize will look. So this shows the importance of nutrients in various production of crops, be it maize, be it wheat, be it horticultural crops, and so forth. So nutrients really is very, very, very important. we may ask ourselves, where do nutrients come from? You can see that, first of all, there are two categories or three categories of the nutrients that come from the soil and the fertilizers. This is primary nutrients, where we have nitrogen, phosphorus, and potassium. These are needed in large quantities by the plant. Then we have secondary nutrients, magnesium, calcium, and sulfur. Yes. Then the rest is micronutrients. And these are all the ones that I mentioned earlier: manganese, copper, chlorine, molybdenum, zinc, iron, and boron. They are required in small quantities, but they are very, very, very important. Now, the next thing is that from the air, we get hydrogen, oxygen, and carbon. And when you look at it, you realize that 90% of what plant need mass, the plant mass, is really nitrogen, is hydrogen, oxygen, and carbon that come from the air and water. These contribute about 90%. So from the soil, what I've mentioned, and fertilizers is between 9 to 10% plant mass. So whatever also we get from the air is very, very, very important. I mentioned that in the essential nutrients, that there are those absorbed by plant roots that are required in large quantities. So you can see from the slide that there is macronutrients, there is primary, there is secondary, what I've already mentioned. And I've also said that those that are required in limited quantities are micronutrients. This is the same what I've just mentioned. But let me show you that this is a law of the minimum, that the nutrient in less quantity limits the yield. If there is a certain nutrient that is less, know that it's going to limit your yields. For example, the potassium. You can see that, let me call it like a jar or a basket, that it could have all the nutrients in the required amount or quantities. But if one is limiting, and for this case, K, it's going to limit your yield. There are also other factors that affects production, that affects yields. And these are variety, the seeds, the variety of the seed that you are going to plant. Some limitation can come from pest, and others can come from water and even the environment, that is the temperature. So really, even as we address the issue of fertilizing your crop, the crop response can be affected by other factors that I've just mentioned. Somebody may ask, how do you come up with the rate of application? How do you know that maize requires certain quantities of fertilizers, or your tomatoes, or your onions? Basically, this one we can say is by nutrients uptake. So whenever you plant a maize or wheat or tomatoes, is that when the crop is growing, and even at a full cycle, when you are harvesting, if you analyze the nutrients that have been removed by the soil, we can be able to deduct that what is needed for you to be able to produce, say, 1 ton of wheat or rice. We can do the same and be able to tell that, for example, the grain and the straw, after a complete cycle, when you are harvesting, and you analyze what has been removed, really you can find that the grain, for instance, can remove 15 kilos of nitrogen from 1 hectare per ton. The straw will be 8 kilos of nitrogen per ton of produce. Look at phosphorus, it will be 6 kilos and 3 kilos respectively. Potassium, 4 kilos and 30 kilos respectively. So in total, For you to be able to harvest or to produce 1 ton of rice, you are going to require 34 kilos of potassium. So if your target is 5 tons, and you can see how we have tabulated there is that for every 4 kilos of potassium, you get 1 ton. So for 5 tons, you are going to require 170 kilos K2O per hectare. So a crop of rice yielding 5 tons per hectare removes 170 kgs K2O per hectare, 45 kg P2O5, that is phosphorus per hectare, and 165 kilos of nitrogen per hectare. And this goes for the other crops also, wheat, maize, sunflower, all the crops. So when you are going to plant, when you are planning to grow, say for example, onion or tomatoes, you must have this in mind that this is what you are going to harvest. So your yield is direct proportional to what you are going to give in terms of the nutrients. This is the same thing what we have just said, but now these are examples of, say, for example, maize. Now the macro, the secondary, and the micro elements, what is going to be required for you to be able to produce 5 metric tons per hectare. So that first column is what you are going to require. Nitrogen 100 kilos, phosphorus 20 kilos, potassium 100 kilos, calcium 13, and so forth and so forth. And this one goes for rice, wheat, beans, and many other crops that you may be planning to do. I have mentioned micronutrients, and I said that they are also very, very, very important. If we look at, let's look at an instance where you may grow your tomatoes, for instance, like this is an experiment where tomatoes was grown. And from the first picture on your left, you can see that only NPK was applied. And you can see how that plant looked like. But come to the second picture at the middle, where you see NPK plus trace element or micro elements, that plant, that crop is healthy. And likewise, on the right, where the crop looks so really malnourished, no fertilizer was applied. So this shows the value of micronutrients. For deficiency to occur in a plant, there are these nutrients that we say they are mobile in nutrients that are mobile. Symptoms in the older leaves. Why? Plant translocate nutrients to the growing organs. So you will be seeing nutrients deficiency in the older leaves. Immobile nutrients, these are the nutrients that are not immobile, and the symptoms shows in the younger leaves. Why? Nutrients can't move. Look at the roles of nutrients. Let's look at the role of nutrients in summary. Micro, or when we start with macronutrients, nitrogen, phosphorus, and potassium, you can see from that diagram provided that nitrogen promotes high yields and ensures vegetative growth of the crops. It plays a key role in synthesis of protein, which are directly involved in growth and yield. Very important. When we come to phosphorus, it is directly involved in developing a good root system, setting a high numbers of tubers, and sustaining cellular division. Phosphorus, very important. Out of the three, nitrogen, phosphorus, and potassium, phosphorus is needed not much. It's a little as compared to nitrogen and potassium, but performs very critical function. It also provides energy for the plant process. Phosphorus can increase the percent of starch and dry matter. It's very important. Let's go to potassium. Potassium is really required in large quantities. It is important in all plant stages, right from planting until finishing. You realize potassium is required in all stages. Due to the mobility, it regulates water management, reducing the incidence of stress factors, transporting of sugars, and directly involved in yield increase. So this is very important, very critical, that it is directly involved in yield increase. Let's go to the deficiency when you don't, when your crop is suffering from some of the deficiency of macro. So look at nitrogen deficiency. From that diagram, from that photo, you can see various trials that have been done, and you can see yellow, some of the plant looking pale, or some a bit of yellowish, and others green. So one of the deficiency is that lack of nitrogen. For instance, in maize, the maize will look palish or yellow. So this is very, very, very important. So this requires top dress. It's very, very important. Let's go to phosphorus. When you look at the corn grown in light soils, the photo on your left, it shows phosphorus deficiency. Purple leaves, there is this purple leaf. This is a classical example showing phosphorus deficiency in corn or maize. After treatment with phosphorus treatment program, that's how your maize look like. Very green, very nice. And this one really, from the observation, you can tell that you are going to have some good production. Potassium. So if you have seen in your leaf some at the edges of the leaf, you can see some brownish. And even mostly that's how it shows. You see brownish at the edge of the leaf. You know, basically that is potassium deficiency. Look at the carrot, the size. This is also a very, very classical, because you can see the carrot that has -K, they look small, they look thin, but with potassium, they look nice, big in size, attractive color. Same applies to the cucumber. You can see that cucumber, that deep green color, big in size. But you see the one without potassium, it's pale and the size is small. The same case applies to the tomatoes and even the eggplant. Look at this also. This also tells you the classical example. It shows you where potassium has been used, the fruits are bigger in size. Without potassium, the fruit are smaller. Same case to bananas. You can see on the left side, the way the banana look like, not attractive to the eye, really. The shelf life, you can see. The more it stays, like in this case, after 19 days in storage, the crop, the banana without potassium, see how it looks. But look at the one where potassium was used. It looks very nice. The color is still there, and it's still attractive. Let's go to the role of secondary nutrients, that is calcium, magnesium, and sulfur. From calcium, we can see that it promotes the cell stability by building a strong structure, providing stress resistant for summer heat or during hot weather. Actually, calcium, we can say it's like it acts like a cement in the construction industry. The incidence of bruising at harvest is reduced by applying the right level of calcium, and therefore transport and storage are improved as well. Very, very, very important. You see the need why calcium is needed in potatoes, in tomatoes, even in fruits, especially when you have to transport it longer distance to reach your markets. Magnesium is a central part of chlorophyll molecule, playing a key role in photosynthesis. This is very important. For any reaction, for any photosynthetic reaction to happen, magnesium has to be there because it's the center part, the central part of the chlorophyll molecule. It is directly involved in yield, being a good transporter for sugars from the leaf to the tubers. Very important nutrient. Sulfur increases plant resistance to various types of scab, that is some scab, some diseases, and the synthesis of essential amino acids. Straight to the deficiency of calcium, we can see from the photos, blossom end rot in both tomato and pepper. And this really is caused by calcium deficiency in the fruit apex. Very important. This we have seen in the market. We have seen this causing a lot of damages, a lot of losses in post-harvest. Most of the tomatoes are reaching the market because this you cannot sell. So it has to be graded out. Magnesium, that is a deficiency. You can see in the leaves some marginals. You can see some lines of yellowing on the leaf. So that one is a classical example of magnesium deficiency. Sulfur. This one may be confused by deficiency of nitrogen. So it's good to be a bit keen when you're observing this. You can see how that leaf is behaving. Some lines of yellowing. That shows sulfur deficiency. The role of micronutrients, that is iron, very fast, is performing. It's concerned in chlorophyll synthesis, so it's part of the chlorophyll synthesis during that reaction. In manganese, it's working in synergy with magnesium, helping in photosynthetic process. Boron is important in plant metabolism and pollination. Very, very important, especially in coffee, in tomatoes. Is very important. Improving also it improves the root system, shoot development, and calcium uptake. So boron is also very, very, very important. So if you are seeing if you're observing, or if you have observed some deficiency of calcium, it's good also to apply together with boron, because boron aids calcium uptake. Zinc promotes protein synthesis, starch formation, and is acting as a binding agent for magnesium and manganese. Very important. Copper is playing a role in the metabolism of nitrogen and carbohydrates. The last one there is molybdenum, is part of the nitrate reductase, where nitrate molecule binds to the active site with the molybdenum ion. Ion deficiencies, this is how it looks like. So if you come across a field of your corn that look like that, you know straight away that is an iron deficiency. There is looking like some chlorosis of the leaves. Look at the down photo, younger leaf showing that. Manganese, this one is also almost the same as sulfur deficiency. Yeah, but you can see this one is well expressed. You can see it even from far. Boron deficiency of tomato. This you may have seen, because look at even the fruits. So This is a classical example of boron deficiency. Copper, of which you can see deficient in wheat. This is very, very important, and that's where you see that copper is really used in large quantities, especially in wheat. So your feeding regime will not be complete without copper. Molybdenum, that's how, look at the leaf of the kales, curling and shriveled. Look at the leaves of tomato. You may even think it has been affected by mites, the way it looks like. That shows clear example of deficiency. And even the leaf tips, you can see some purpling. So that shows classical example of molybdenum. The last one in our deficiency of microelement is chloride. Yes, in many literature it's not mentioned, but if you come across your cabbages looking like this, just know that that is chloride deficiency. I want to go to this point of before using your nutrients, before applying your fertilizers, it's good to know the range of your soil pH. Optimum pH for all these nutrients where they'll be available to the plant is between 5.5 to 6.5. So within that range, all these nutrients that I've spoken about, the macro and the micro, will be available to the plant. But when you find your soils has got higher pH, so more pH values reduces nutrient availability. And likewise, low pH values reduces the nutrient availability and also increase toxicity levels of aluminum and manganese. So it's good to know the status of your soil so that all these nutrients that we are applying in terms of fertilizers can be efficiently be uptaken. This is an example of all these crops within which range, the pH range, that you can be able to grow these crops. For example, the carrot, the pH is indicated there. Tomato 6 to 7, cucumber 5.5 to all the way to 7.6. You can grow your cucumber cabbages 5.7 to 6.7. Cabbages I've mentioned. So all of them, potato 5.5 to 6.5. So these are the range, the different range, soil pH range for common vegetables that we need to make sure they are there. So when your soil is low in pH, we will be forced to do some amendments of lining your soil so that we can bring the pH up to that range that the crop that you want to grow can be grown, and all these nutrients that we are talking about can be efficiently be uptaken. Sometimes when you are growing, so depending whether you want to set up a fertilizer program for, say, for example, outdoor, the broad acre, the farm is out there, is depending on the rainfall. So there is a regime for that. And this requires granular fertilizers that will be applied. And we'll come to this at a later stage. And also this also depends whether you are going to broadcast or to microdose or even do a raw application. It all depends with how you want to grow your maize, your onion, your tomato, or whatever crop, or even French beans. It all depends which crop you are doing. And the method of fertilizer application, for example, if it is potato, the recommended one, mostly you can do it like a raw application will be recommended. If you are fully under drip irrigation, you'll be forced to look for fertigation for water-soluble fertilizers. So this is very important. So if you have installed drip irrigation, there are some fertilizers that are required, which are water-soluble, that you can use for your production. Foliar feeding, this is especially when you are applying microelements or when you observe some, some deficiency that you cannot be able to place. Is it sulfur? Is it nitrogen? Sometimes you can even boost. You can boost your crop by applying foliar, because this one is very, 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 very good, as it also helps the plant to uptake the other nutrients from the soil. So this will come at a later stage, but as a rule of thumb, know that this one can be, some of them can be incorporated when you are doing your crop protection. It's also good to look at the factors like the drought and the hot temperatures or wind, so that the plant can be able to uptake the nutrients through the foliar feeding. As I conclude my presentation about the basic crop nutrition, I want to say that in the coming weeks, we'll be going now into details of, say, for example, when we speak about fertilizer regime for onion, tomatoes, or potatoes, we'll go into details what it requires. We'll also be speaking about the status of the soil, the pH of the soil. If the soil that have low pH or they're acidic, we'll speak about how we can do liming, what will be the rate of liming, so forth and so forth. So we'll tackle step by step, one by one, about the feeding regime of various crops. We'll share with you some trials that we have done that have shown very good response in relation to the various types of other fertilizers that we have in Elgon, and the various solutions really that we as Elgon, we can provide. We have our agronomists out there. I'm also an agronomist. So please share your questions, drop your notes, your questions, your remarks, and we'll go through them together. You can also share your questions with our WhatsApp number, which I'm going to give you, and I'll also share later on in our presentation, in forthcoming presentation, 0110 094 464, and also you can call direct to Jeremiah 0722 254 102. Feel free to raise your queries, your remarks, or probably you may want us to tackle a certain topic in terms of the crop nutrition. Please feel free, because we'll tackle them together with you. We'll share more information that we may have. In our program, forthcoming programs, we'll also come up with other experts so that we can be able to tackle various questions, topics that you may have raised, and together, because at the end of the day, we want you farmers to be successful. I've always said that let's treat farming as a business. It's not now like hobby the way it used to be. Let it be business. And if it is business, we have to follow the right channel of production. Seek information, we have information. We have good products. We have right products. We have fertilizers that really can give you very good yields. Thank you very much. See you next time. Asante sana.